Welcome to today's deep dive. I mean, you, our resident learner, are in for a seriously wild ride today.
Oh, absolutely. It's a completely jarring topic to wrap your head around.
It really is. So I want you to picture this. Imagine walking into the psychiatric ward of New York's Bellevue Hospital. It's the spring of 1969.
Okay, setting the scene.
Yeah. And you are not a doctor making rounds, right? And you're not a patient seeking treatment. You are a completely healthy volunteer just sitting on a hospital bed.
Right.
And you're watching a researcher prepare this highly calculated dose of amphetamines. And the explicit stated goal of this medical professional standing in front of you is to intentionally trigger a severe, terrifying, psychotic break in your mind.
Which is just a profoundly shocking image, especially when
Yeah.
you try to reconcile it with our modern understanding of medicine.
Oh, 100%.
I mean, we tend to view psychiatric care as this discipline that's focused entirely on pulling people out of madness, right? Not pushing them into it.
Exactly. And that tension, that exact shock value, is why we are doing this deep dive today. We're exploring this really fascinating article from Psychology Today by Dr. Justin Garson.
It's a great piece.
It is. It details how American psychiatry essentially built its entire modern focus on brain chemistry, because the foundation of the medications that, millions of people rely on today, it wasn't poured in some sterile, predictable vacuum.
No, not at all.
It was built on some incredibly bold, dangerous, and sometimes highly controversial experiments, specifically this 1969 effort to artificially create schizophrenia in a laboratory.
Yeah, and to really understand this piece of medical history, we kind of had to spend our modern judgments for a minute.
Right, because it sounds crazy today.
Totally. When we unpack the mechanics of a doctor deliberately inducing psychosis, I mean, it sounds like something straight out of a horror film.
It really does.
But we have to view these actions through the lens of a medical field that was, at that specific moment in the 1960s, completely paralyzed. They were just desperate for answers and unable to help people who were really suffering.
Okay, so let's pull back and look at that paralysis. What did the landscape of psychiatry actually look like for, say, a doctor walking the halls of a ward in the mid-1960s?
Well, it was defined by this just profound sense of helplessness. Because at the time, there was absolutely no cure for schizophrenia.
None at all.
Right, none. I mean, antipsychotic drugs did exist, but they were incredibly crude. We are talking about early generation tranquilizers.
Okay, so what did those do exactly?
They might, suppress some of the most visible agitation in some patients, but they left a lot of others essentially unchanged. The core delusions were still there.
Wow.
And for the patients who did actually respond, the side effects were often just physically debilitating. You'd see severe tremors, intense lethargy, muscle rigidity.
That sounds awful.
It was. Doctors were basically forced to use these really blunt instruments to treat a condition they didn't really understand at all.
You can just imagine the toll that takes on a physician, right? You go to work every single day, you watch people trapped in these delusions they can't escape, and the only tools in your bag barely work.
Exactly. And they cause a tremendous amount of collateral damage.
Right. So out of that environment, this incredibly radical conjecture starts to take shape among a subset of researchers.
Yeah, they decided to just invert the entire problem.
Right. Instead of blindly searching for a drug that could cure schizophrenia, they started asking, well, what if we could find a drug that reliably creates it?
Which is such a wild pivot. But the logic was rooted in a very specific scientific philosophy.
Which was?
Basically, if you cannot understand a natural disease because it's just too complex and unpredictable, you try to build a synthetic model of it.
Okay, I love this part. It reminds me of trying to fix a completely sealed, broken machine, like an engine.
Oh, that's a good analogy.
Right, like you can't just take a hammer to a sealed engine and hope for the best, but if you have a perfectly functioning engine and you intentionally break it in a very specific, documented way.
You suddenly have a blueprint.
Exactly. By studying the precise mechanism of how you broke the working engine, you might uncover the reverse engineering needed to fix the originally broken one.
That is the exact mechanism of discovery they were hoping for here. Finding a quote-unquote madness-mimicking drug offered this twofold promise.
Okay, what was the first part?
First, it offered an unprecedented window into the subjective experience of the disease. Doctors could theoretically take this drug themselves, temporarily step across the boundary of reality, and develop actual clinical empathy for their patients.
Just the sheer psychological fortitude required to willingly submit yourself to that is astounding to me.
Oh, completely. It's incredibly brave.
Right.
And beyond the empathy, there was this massive biological imperative.
Right, finding the root cause.
Exactly. If they could identify the chemical that caused the madness, they could track how it interacted with the brain. And that chemical pathway might just be the map that led them to the biological roots of schizophrenia itself.
Okay, but let's unpack this reverse engineering idea for a second, because I'm looking at the history here, and this wasn't entirely new in the 60s, was it?
No, it wasn't.
Because in the 1950s, the psychiatric community was heavily invested in experimenting with LSD for this exact purpose, right?
Yeah, they were. The LSD project was huge.
They were taking it, giving it to volunteers, trying to induce madness. So why didn't that work? I mean, doesn't a heavy dose of LSD completely shatter your grip on reality?
Well, yes, it shatters reality, but the nature of the shattering is completely different. By the early 1960s, researchers realized that LSD was essentially a failed model for schizophrenia.
Really? Why? What were the key differences they were seeing in clinical observation?
So when you look at an LSD-induced state, the hallucinations are primarily visual. The subject often sees, like, geometric patterns, shifting colors, walls melting.
Classic psychedelic stuff.
Right. And crucially, they often retain this sliver of insight that they're actually under the influence of a drug. They know they took something.
Oh, interesting. And schizophrenia doesn't look like that.
No, schizophrenia rarely presents with those kinds of geometric visual hallucinations. The delusions are far more insidious.
Like auditory hallucinations.
Exactly. They involve hearing complex, threatening voices. They develop these really deep paranoid belief systems. And they experience a complete, terrifying loss of insight. They don't know it's a disease.
So the LSD experience was just the wrong chemical key. It didn't open the door to the specific pathology of schizophrenia at all.
Exactly. It was a dead end.
So they have this brilliant theory of reverse engineering, but their primary tool is totally useless. They're basically back to square one, trapped in the same helpless wards.
Yeah, until the narrative shifts away from the pristine laboratories and moves directly onto the streets of Manhattan.
Yes. Okay, this brings us to Dr. Burton Angrist. In the 1960s, he was this young assistant professor of psychiatry at NYU, right? And he's conducting research and treating patients in the psychiatric ward at Bellevue Hospital.
And Bellevue is, well, it's an institution that has always sat at the absolute intersection of urban life and mental health crises. It sees everything.
And Angrist is experiencing all the frustration we just talked about. He sees firsthand that trying to talk someone out of a fixed paranoid delusion using traditional psychoanalysis is just completely ineffective.
It doesn't work. He was convinced the answer had to be biological.
And right at the height of his professional frustration, New York City experiences a massive, sprawling amphetamine epidemic.
Huge. We are talking about thousands of people injecting massive quantities of speed on the streets for days on end.
Right. And the fallout from that epidemic began flooding through the doors of the Bellevue emergency room.
It did. And Angrist starts taking clinical notes on these patients. And he notices a pattern that must have felt like an absolute lightning strike.
What was he seeing?
The people coming in after these multi-day amphetamine binges, they weren't presenting with the visual, colorful trips of the LSD users. They were presenting with symptoms that looked clinically indistinguishable from severe paranoid schizophrenia.
Wow. The mimicry was that profound.
Yes. These amphetamine users were suffering from intense auditory hallucinations. They were hearing menacing, invisible voices plotting against them.
Just like organic schizophrenia.
Exactly. And their speech was degrading into this condition we call a formal thought disorder. It's where the logical bridges between ideas completely collapse, resulting in these fragmented, nonsensical riddles.
It was so convincing that the highly trained psychiatric staff at Bellevue were literally misdiagnosing them, right?
Yes, routinely. They would admit an amphetamine user, officially chart their condition as schizophrenia, and put them in a bed.
But then what happened?
Well, a day or two later, as the patient's liver metabolized the amphetamines and the drug cleared their bloodstream, the schizophrenia completely vanished.
The psychosis literally just evaporated.
Exactly. Angrist realized he was watching the exact madness-mimicking phenomenon the field had been desperately searching for. It was happening organically in the city, and the drug responsible was amphetamine.
Okay, here is where it gets really interesting to me, because this raises the classic scientific problem of correlation versus causation.
Oh, absolutely.
If these are individuals being pulled off the street after an extensive drug binge, they probably haven't slept in 3 or 4 days, right?
Right. Sleep deprivation is huge.
Plus, they're taking street-level narcotics mixed with who knows what. As a scientist, how could Angrist possibly look at that chaotic scenario and definitively say, the chemical structure of the amphetamine is causing this psychosis?
He couldn't. Not definitively.
Right. Couldn't the hallucinations just be the brain breaking down from extreme lack of sleep? Or maybe these people already had underlying psychiatric conditions that the stress of the binge simply exposed.
Yes, and those are the exact confounding variables that stood between Angrist's observation and scientific fact. In the medical community, you cannot claim a biological mechanism based on chaotic emergency room anecdotes. The latent illnesses, the sleep deprivation, the questionable purity of the street drugs, all of these factors provided alternative explanations for the psychosis.
So, as long as those variables existed, the amphetamine theory would just be dismissed as a side effect of urban drug abuse, not a key to understanding schizophrenia.
Exactly. Which forced Angrist into a highly controversial position.
Because to strip away the variables and isolate the chemical, he had to take the chaos of the street and reproduce it in a sterile, controlled environment.
He had to bring the epidemic inside the hospital.
Which brings us back to where we started, the spring of 1969 and the experiment that fundamentally altered the trajectory of modern neurochemistry.
Yes, Angrist initiated a protocol to intentionally induce this state. He gathered 4 volunteers.
Now, it's a crucial detail to share with you listening. These were not random, naive college students looking for quick cash, right?
No. They were all experienced amphetamine users, whom Angrist had previously encountered in a clinical setting at Bellevue.
Even with that context, the sheer mechanics of what happened in that room are just harrowing.
They really are. Now, Angrist didn't just give them a massive, overwhelming dose of speed all at once. He knew that would risk catastrophic cardiovascular failure.
Right, you can't just shock the heart like that.
Exactly. The protocol required a slow, methodical push to the edge of sanity. He employed a gradual, cumulative dosing schedule.
So what did that look like?
He brought them into the ward individually, starting them on relatively moderate doses, somewhere between 10 to 20 milligrams of pure pharmaceutical-grade amphetamine.
And then they just waited. Every single hour, on the hour, Angrist administered another 10 to 20 milligram dose.
He sat right there in the room with them.
Yeah, and a nurse was stationed right there, constantly taking their blood pressure and monitoring their heart rate to ensure their bodies weren't failing under the strain.
Just feeding the brain more and more of the chemical, waiting for reality to break.
From a purely observational standpoint, the results were incredibly precise, even as they were terrifying for the subjects.
Completely terrifying.
I was reading the case file detailed in the source material,
Yeah.
and they really anchor the severity of this. Take the patient identified as Subject A.
Right, subject A.
Within about 20 hours of this relentless hourly dosing, his mind completely fractured. He didn't see geometric shapes like on LSD. He developed a deeply paranoid, complex delusion.
Yeah, he became absolutely convinced that an unbearable, foul stench was emanating from his own skin.
That is so dark.
It is. And what's fascinating here is that specific type of somatic delusion, a false fixed belief about one's own physical body, is a hallmark of paranoid schizophrenia.
Wow. And it escalated from there, didn't it?
It did. Subject A then developed the belief that unseen individuals had been planted in an adjacent building specifically to monitor him.
The profound terror of sitting in a hospital bed while your own brain constructs a conspiracy around you is just difficult to fathom.
Truly.
And the reaction of Subject D was entirely different, but equally indicative of the disease. Subject D's psychosis attacked the structure of his intellect.
Right, he developed that formal thought disorder we discussed earlier. The internal logic that governs how we connect concepts and form sentences just disintegrated.
He became convinced he was a religious prophet. He sat in the ward, frantically scribbling page after page of completely disconnected, nonsensical musings. Words and ideas were just pouring out of him without any anchor to reality.
What Angrist achieved in that room, despite the intense psychological suffering of those volunteers, was the ultimate proof of his theory.
Because he controlled all the variables.
Exactly. By tightly controlling the dosing, ensuring the patients weren't sleep-deprived when the experiment began, and using pure amphetamine, he eliminated the confounding variables. He proved unequivocally that the amphetamine molecule itself was the direct cause of the psychosis.
He had successfully manufactured a temporary model of schizophrenia in a lab.
He did.
Having the ability to turn the disease on and off in a lab setting is obviously a massive leap forward. But how does that actually help the patient suffering organically? I mean, identifying the poison doesn't automatically give you the antidote, right?
Well, it doesn't give you the antidote immediately, no,
Mm.
but it gives you the mechanism. And in biology, understanding the mechanism is everything.
Okay, makes sense.
Once the scientific community accepted that amphetamines could reliably mimic schizophrenia, the focus of global research shifted almost overnight. Scientists stopped asking, what is schizophrenia? And started asking, what exactly do amphetamines do when they enter the human brain?
And this is where the narrative cascades into the fundamental discoveries of modern neuroscience. Because in 1970, just a year after the Bellevue experiment, a neuroscientist and psychiatrist named Solomon Snyder gets involved.
Right. Snyder reads about Angrist's work and decides to trace that exact chemical pathway. He begins investigating the microscopic interactions happening at the synapses.
Which are the tiny gaps between our brain cells where communication occurs.
Exactly. And Snyder makes a monumental breakthrough. He discovers that when amphetamines enter the system, they don't just randomly scramble the brain's wiring.
Right. What do?
They act very specifically to force the brain to dump massive, overwhelming amounts of a single neurotransmitter into those synapses. And that neurotransmitter is dopamine.
Dopamine. Wow. So the amphetamines essentially jam the brain's chemical release valves open, flooding the neural pathways with dopamine.
Yes. And this specific observation triggers an earthquake in psychiatric theory. Because if we know that flooding the brain with dopamine artificially creates schizophrenia,
Then the logical leap is that actual organic schizophrenia must be caused by a natural dysfunction of the dopamine system.
exactly, maybe the patient's brain is producing too much or it's too sensitive to it. This became universally known as the dopamine hypothesis.
That is a huge paradigm shift.
Huge. It fundamentally shifted the entire field of mental health from psychological theories to concrete neurochemistry. And Solomon Snyder's lab didn't stop at the hypothesis. 5 years later, in 1975, they achieved something even more critical.
What was that?
They actually discovered the physical structures in the brain that respond to dopamine.
The dopamine receptors.
Yes. If dopamine is the chemical messenger carrying the signal, the receptor is the cellular docking bay that receives it.
Uh-huh.
Snyder's lab proved that the brain is lined with these specific receptors.
Okay.
And most importantly for the treatment of patients, they tested all of those early, crude antipsychotic drugs against these newly discovered receptors.
And what did they find?
They found a direct mechanical correlation. They proved that every single effective antipsychotic drug works by physically blocking those dopamine receptors.
Oh, wow. So let me use an analogy here. If the excessive dopamine is like a massive fleet of cars speeding down the highway causing the psychosis, the antipsychotic drugs act like concrete barriers parked in the designated parking spots at the destination. The dopamine cars are still on the highway, but they have nowhere to dock. The signal is blocked and the psychosis subsides.
That is an excellent way to visualize the mechanism.
Yeah.
And for decades, this provided an incredibly compelling, elegant narrative for psychiatry.
Right. But, so what does this all mean for us today? Looking at it from our vantage point, 50 years later, is the human brain really that simple? Like a simple light switch turn the dopamine down and the schizophrenia turns off? Does severe mental illness really boil down to a single chemical highway having too much traffic?
Well, no, it doesn't. And that is the crucial nuance we really have to apply today.
Right.
The dopamine hypothesis was a monumental breakthrough, absolutely. But we now know it's an incomplete picture. The brain is not a simple machine with a single chemical lever.
The source material touches on this, noting that our modern understanding recognizes schizophrenia as an incredibly complex mesh of multiple neurotransmitters, overlapping neural circuits, and compounding environmental factors.
Yes, we've realized that dopamine is a major player, perhaps the most visible one, but it is not the only variable. In fact, contemporary psychiatry increasingly views schizophrenia not as one unified disease, but as a cluster of related conditions with varied underlying biological causes that just happen to produce similar symptoms on the surface.
So the simple dopamine theory wasn't the final answer, but Angrist's 1969 experiment was the wedge that cracked the door open.
Exactly. It forced the medical world to finally look at the chemical architecture of the brain.
But as we look at the legacy of that breakthrough, we really have to grapple with the reality of how it was achieved. Because the ethical implications of intentionally inducing severe psychosis in human subjects, that cannot be glossed over, no matter how valuable the resulting data was.
No, it can't. And it shouldn't be.
Now, Dr. Angrist went on to have a long, incredibly vital career before his death in May of 2024. He didn't just walk away after the amphetamine study.
Right? He had a lot of good work.
He pioneered the early use of PE scans to visualize the living brain of patients, and he spent years trying to mitigate those awful, debilitating movement side effects caused by the early dopamine-blocking drugs. He dedicated his life to refining the treatments. But looking back at 1969, I just can't imagine a modern medical ethics board even letting him finish the sentence if he proposed that experiment today.
Oh, they absolutely wouldn't. And Angrist himself was fully aware of that.
Really? Did he talk about it?
He did. In a reflection he published in 1994, looking back on his work at Bellevue 25 years later, he openly conceded that the experiment would be considered unethical by modern standards.
I mean, even in the context of the 1960s, a doctor has to know that pushing a human mind to the point where it believes it is rotting from the inside is a profound violation of the do no harm principle. Did he offer a defense for crossing that line?
If we connect this to the bigger picture, he did offer a defense, and it rests entirely on the context of the era. He pointed out that the rigid institutional review boards we rely on today simply did not exist in the same form. But more substantially, he argued that he took extreme precautions within the ethical framework available to him at the time.
Like the gradual dosing and the constant vital checks by the nurse?
Yes. He prioritized the physical safety of the subjects to ensure they wouldn't suffer a stroke or cardiac arrest. But his ultimate defense circles back to where we started our discussion today, the sheer crushing desperation of the psychiatric wards.
Right.
He was surrounded by a disease that was destroying thousands of lives, and traditional medicine had nothing to offer but sedatives and failure.
So he believed the moral imperative to find a mechanism for a cure outweighed the temporary, intensely monitored suffering of 4 volunteers.
Exactly. It highlights the eternal, incredibly uncomfortable tension in medical science. You know, how much collateral damage is acceptable in the pursuit of a breakthrough that could save millions.
It is a question that just doesn't have a clean answer. Angrist's work at Bellevue sits directly on that fault line between urgent medical necessity and the rigid boundaries of human experimentation.
It really does.
When you look at the trajectory we've tracked today, it is staggering. We started in wards filled with doctors who had no viable tools, relying on talk therapy to combat biological hallucinations.
We observed the organic chaos of a Manhattan drug epidemic, which provided a terrifying but accurate mimicry of the disease.
We looked closely at a highly controversial, dangerous decision to bring that epidemic into a hospital, methodically dosing experienced users until their minds fractured just to prove a chemical link.
And we traced how that single agonizing proof provided the foundation for Solomon Snyder to map the brain's dopamine pathways, fundamentally rewriting the rules of psychiatric medicine forever.
It honestly changes the way you look at a modern pharmacy.
Doesn't it?
The clean, sterile rows of pill bottles, the neatly printed labels, the precise dosages, that entire structure of certainty is resting on a foundation of desperate, messy, and boundary-pushing risks taken decades ago. Progress is rarely pristine.
No, and progress is also rarely finished. The realization that our early breakthroughs were overly simplistic guarantees that there are more paradigm shifts waiting to be discovered.
Which brings up a fascinating thought to leave you on today. If modern science is increasingly realizing that schizophrenia is not a single disease, but a cluster of different overlapping conditions we've simply grouped together because we lack the tools to differentiate them, what else are we mislabeling?
That's a great question.
How many other major household name mental health diagnoses are actually umbrellas covering 3, 4, or 5 entirely different biological misfires? We might just be waiting for the next accidental discovery to show us we've been using the wrong chemical key all along. Something to think about the next time you marvel at the certainty of modern medicine. Until next time.